Hey guys, today's topic is going to be formal logic, the basics of deductive arguments. Now, this is not my wheelhouse. I don't know much about this, so my brother's actually going to be presenting this one. His name's Nate, so I'll go ahead and give it over to him.
Hey guys, this is Nate. I'm Jason's brother. I know this isn't strictly speaking science, but being able to evaluate and form your own arguments is really a super important skill no matter what field you go into. So this information may still be helpful, or even if you don't care about logic at all. Let's start with a couple concepts and definitions about formal logic. The first thing is an argument. An argument is a set of statements with one of them being the conclusion, which is the thing that's being argued, and the rest being premises, or reasons for accepting the conclusion. A term that you hear a lot is validity. It has a very technical meaning when it comes to logic. An argument is valid if and only if it is impossible for the premises to be true and the conclusion false. Validity is purely formal. It has nothing to do with the actual truth value of any of the sentences in the real world. An argument can have all true premises and a true conclusion, yet be deductively invalid. Another term you hear often is a sound argument. A sound argument is just a valid argument with all true premises. Here's an example of a valid argument. 1. If it is raining, then I carry an umbrella. 2. It is raining. 3. Therefore, I am carrying an umbrella. This argument is valid because if the premises are all true, then it is impossible for the conclusion to be false thanks to the logical form of the sentences. Next, let's talk about logical forms, specifically connectives. The logical form of a proposition P tells us exactly what the proposition is saying and under what conditions it is true or false. It can be expressed using the connectives in the logical language. The first connective is the conjunction or the dot. P dot Q essentially means P and Q. The truth conditions is that P dot Q is only true when both P and Q are both true. Next is the disjunction, P wedge Q, or P or Q. The truth conditions for this is that P wedge Q is only false when both P and Q are false. The next is negation, or tilde P, which essentially means not P. This is very obvious. The truth conditions, not P is true when P is false, and not P is false when P is true. The next connective is the material conditional, aka P horseshoe Q. This means if P, then Q. The truth conditions are that P horseshoe Q is false only when P is true and Q is false. The sentence on the left of the horseshoe is known as the antecedent, and the sentence on the right is the consequent. The next connective is the material biconditional, or the tribar. P tribar Q essentially means P is logically equivalent to Q. The truth conditions for the tribar are such that P tribar Q is false when the truth values of P and Q are different, aka when P is true and Q is false, or the other way around. Next, let's talk about some of the valid argument forms for inference. These are essentially the rules that you use when you're doing a proof, trying to prove that an argument is valid. The first one is modus ponens, and it has the form of P horseshoe Q, and then P, therefore Q. This is very intuitive. An example of this is that if I am a dog, then I am a mammal. I am a dog, therefore I am a mammal. The next rule is modus tollens, which is sort of the inverse of modus ponens. Modus tollens has the form of P horseshoe Q, tilde Q, therefore tilde P. An example of a modus tollens argument would be, if Jason lives in LA, then Jason lives in California. Jason does not live in California, therefore we can be sure that Jason does not live in LA. There are certain common fallacies involved with modus ponens and modus tollens that are often tricky. The first one is affirming the consequent. If you have P horseshoe Q and Q, you may be tempted to say, therefore P. This is wrong, however. An example would be, if I am a dog, then I am a mammal. I am a mammal, therefore I am a dog. This is obviously incorrect. Another common fallacy is denying the antecedent. This would take the form if you have P horseshoe Q, and then you have tilde P, you may be tempted to infer tilde Q. An example of this would be, if Jason lives in LA, then Jason lives in California. Jason does not live in LA, therefore Jason does not live in California. While not quite as obvious as affirming the consequent, this is also invalid. What if he lived in San Francisco? The next valid argument form is disjunctive syllogism. DS takes the form of P wedge Q and then tilde Q, therefore P. An example of a DS argument would be, Jason has a dog or a parrot. Jason does not have a parrot, therefore Jason has a dog. The next argument form is simplification. It takes the form of P.Q, therefore P. An example is, Jason wears a shirt and Jason wears pants, therefore Jason wears a shirt. While mechanically this may seem confusing, it's fairly intuitive as you are just specifying one item of a conjunction. The next argument form is conjunction, which is the opposite of simplification. It takes the form of P and then Q, therefore P.Q. An example of this is, I have a pen and I have a pencil, therefore I have a pen and a pencil. This argument form serves to combine two propositions already present in your premises. The sixth valid argument form is hypothetical syllogism. It takes the form of P horseshoe Q, then Q horseshoe R, therefore P horseshoe R. You can think of it as eliminating the middleman with two material conditionals. An example of such an argument would be, if I am a human, then I am a primate. If I am a primate, then I am a mammal. Therefore, if I am a human, then I am a mammal. The seventh rule is addition, also known as weakening. It goes by the form of P, therefore P wedge Q, where Q is any proposition whatsoever. An example of this is something along the lines of, I have a pen, therefore I have a pen or a pencil. The final valid argument forms for inference is number 8, aka constructive dilemma. This rule is not used very often, but it still has a place in the system. It goes by the form of 1 P wedge Q, and then P horseshoe R, and then Q horseshoe S, therefore R wedge S. An example of such an argument form would be, I have a pencil or a pen. If I have a pencil, then I am writing with lead. If I have a pen, then I am writing with ink. Therefore, I am writing with lead or I am writing with ink. Let's try and apply all these rules to an argument to prove validity. When given an argument, there are two things you must look at. First, the premises that you will be applying the rules to in order to get the conclusion. Second, if you look at the bottom right, you'll see the conclusion, which is what you're trying to prove. In this case, it's L. We are looking for rules that we can use to infer information that will let us infer L. The first step is to look really closely at the premises and try to figure out which rules we can use to make progress. Here are the premises written out in an argument. If you look really closely, you'll notice that there's a rule that we can use with lines 1 and line 3. That rule is disjunctive syllogism, because we have tilde A in line 1 and then A wedge D in line 3. Now that we've gotten D, we need to figure out how we can use D to get something else, to get something else, to get the conclusion. It's a little bit confusing, but once you develop the right instincts, you'll be able to see through all of these arguments and just know what to do. It's just a matter of practice. The key to the next step involves looking at line 4. We've just inferred D, and we need to get D wedge U so that we can get C. We use addition to get D wedge U, which can be used in line 4. We use modus ponens on line 2 and line 8 to get the conclusion L, which means we're done. We've solved this proof and we've proved it valid. Keep in mind, these are the basics of logic. These are the first 8 rules of inference. There are about 10 more rules of equivalence, and then 2 more rules, conditional proof and indirect proof afterwards. So proofs can get pretty hard and pretty confusing. However, with just these first 8 rules, it's pretty simple. Anyways, that's it for now. Thank you guys for watching. I hope you learned something. And if you want to see more logic, smash like and tell Jason logic is cool.